Welcome back. This is Unit P19. This is reflection, and this will be the third of our flipped videos. We've already covered reflection, the law of reflection, specular reflection, and now we are down to, already done diffuse reflection. Now we're down here to mirrors. Alrighty. Mirrors. Mirrors are devices that are designed to reflect incident waves. The most common type of mirrors are metal surfaces covered with a thin protective coating of glass or plastic. Other devices, such as dishes on dish antennas, act as mirrors for frequencies other than visible light. Alright, a mirror. All a mirror is something designed to reflect a wave. Our most common usage of the term mirror is for those things that we find in people's bathrooms or in bedrooms and in washrooms. These are things that you look into and you see yourself. And in that respect, we could actually use the old term, a looking glass, to describe what these things are. They are designed to give an exact image. They are designed to give exactly what you're supposed to, what you have in front of the mirror. It's designed to reflect exactly what is in front of it. We don't want any color distortion. We don't want any shapes distorted or anything like that. There's tons of other types of mirrors. All right, we have the mirrors that we use in automobiles, the ones on the passenger side and the ones on the driver's side. Very different. One is a plane mirror, one is a convex mirror. And they have very different properties. But the essential thing is a mirror is something that is designed to go and reflect a wave. Radio antennas, all right, the large dish antennas, those are mirrors. They reflect the radio waves and concentrate it to one spot. We were talking last time about the dishes on for satellite TVs. Those are mirrors. You can have in the microwave part of the spectrum. You can have dishes or mirrors that work in the infrared and the ultraviolet part of the spectrum. Inside complicated devices used in research, there are mirrors for X-rays. All a mirror is something that is designed to reflect a wave in a particular direction. You can even have acoustic mirrors. One of the many things that you find in different concert halls, particularly things that deal with a variety of different types of music, like classical music, folk music, popular music, things like that. There are panels inside there that are movable, and these are acoustic mirrors. They're designed to be moved into place, change position, change directions, things like that, depending upon what type of music is being played, so that you can tune the auditorium, tune the space to reflect the sound properly, so everybody in the venue, everybody in the auditorium can actually hear really, really well, and not have spots that are dead or have echoes or things like that, which has been a problem with a lot of music halls, a lot of concert halls and things like that in years gone by. So you can use pieces of wood, you can use pieces of metal as acoustic mirrors to focus sound into particular locations. All right. Plane mirrors. Plane mirrors are the most common form of mirrors people use, and these form a virtual image that seems to be located behind the mirror. The distance the image is behind the mirror equals the distance the object is in front of the mirror. Everybody, hopefully, is familiar with a plane mirror. All right, you go into your bathroom and there's this big piece of glass on the wall, and it looks like a window, and on the other side of the window is somebody that looks just like you, except everything is reversed left to right. All right, that's a plane mirror, and you're used to seeing this. I mean, I'd be surprised if there was somebody out there that did not know what a plane mirror was like. The properties of the plane mirror are really simple. Whatever is in front of it, its image will be behind the mirror by a distance equal to the distance that the object is in front of the mirror. The size of the image in the mirror will be exactly the same size as the object is in front of the mirror. All right, when I look in the mirror, I see another Mr. Shafter on the other side. If I head towards the mirror, the other Mr. Shafter heads towards the mirror. If Mr. Shafter walks backwards, okay, the image walks backwards. Yeah, it'd be scary if you started towards the mirror and your image turned around and ran away. That'd be a bad thing, okay? Usually a sign things aren't going well. But the distance between you and the mirror and between your image and the mirror are exactly the same. For plane mirrors, that's all there is to it. I mean, plane as in flat, plane, not plane as in plain vanilla. All right? But that's as simple as plane mirrors are. They're not terribly complicated. Whatever you have in front, you see behind the mirror. Now, this is what's called a virtual image. Light isn't passing into a room on the other side. There's not another bathroom behind your bathroom. There's not another bedroom behind your bedroom that has everything exactly like you got. Light never passes through the mirror. Because the light never passes through the mirror, where that image is, there's no light. There's no light being concentrated there. Therefore, it's what we call a virtual image. All right? Light never passes through that point. So it's what we call a virtual image. All right, that concludes this part. Again, not a terribly long or complicated segment. If you have any questions, email me, post a question onto the forum. If not, we will see you tomorrow. And hopefully we'll be able to move on and do important and interesting things.